Hello, my name is Christopher Fabian and my student ID number is 2105531079 and my lecturer is Prof. Dr. Tjokorda Tirta Nindhia, STMT. And now we're gonna talk about manufacturing processes on chapter 3G until 3J. So we're gonna talk about this on this video. We're gonna talk about sewing, flame cutting or thermal cutting, electrical machining process, and the last one is finish machining operations. So we're gonna talk about sewing. Sewing is the parting of material through the use of narrow cutter, a saw, which contains a series of cutting edges that pass against the work in continuous or reciprocating motion. As the cutter is advanced into the work, material is removed by extended through the entire thickness of the workpiece and severing into two pieces. The chip produced by each tooth is carried in the space between the teeth until the teeth exit the workpiece. The cutter can be in a disc, band, or reciprocating platform. And I have a video here for the example of circular saw. We're gonna talk about this. So this is the part. I think the video is gonna cost us a lot of time. So the basically is the arbor here is stationary. You put the blade on the arbor and it only go like the cutting or the blade edge only go for about 3, or you can just change the diameter that going out from the workpiece. So actually there is a table here and it's gonna cut the workpiece. Now I'm lagging. So on introduction, I talk about sewing, and the circular saw is the most basic about sewing. So circular saw using like this is the table, and you have like saw or blade, and the workpiece just fed into the saw to there. So circular saw for metal cutting are sometimes called cold saws because they don't significantly hit the workpiece like a friction saws do. They often have inserted cutter teeth of carbide rather than teeth form of the blade material, or have cutter segments fastened into the center disc. Blades are sometimes large in a diameter to permit the sawing of bulky workpieces. Curves are considerably wider than those on a bend or hacksaws because the circular blade must be thick enough to provide rigidity. Now we're gonna talk about bend sawing. Bend sawing is the most commonly occurred of operations. Instead of a circular disc, and the saw is endless steel bend with cutting teeth on the one edge. The blade moves at its cuts on one direction. Cutting is continuous and the blade wear is uniform over the whole length of the blade. Since the blade is normally thin, little material is lost to chip waste and power requirements are modest. The workpiece or the blade can be fed manually or mechanically. Machining process 113 for cutting off. The blade is normally horizontal and the fed is mechanically or by gravity. And so you can see here the workpiece is horizontal and the cutter is vertically to make less power because of the gravity. Because if you go like this is the direction is to the bottom. If you go from the bottom to the top on the cutting edges, it's gonna cost a lot of power because the gravity gonna make the workpiece is like unstable. So when you cut, you're gonna fight the gravity and the weight of the workpiece as well. This is the video. I think I'm gonna skip the video because it's gonna be lagging on my laptop. Counter sewing uses a bandsaw. The power band normally moves vertically downward and the workpiece resting on a horizontal table is fed into the moving blade either manually or without power access, or automatically into the moving blade. The cut can be in a straight line or a curved path, depending on the shape of the part to be produced. Counterwork is not common in the tool shops for templates, cams, dies, and fixtures. Flat stock is the most common sheet by this method. The material of other sheet is also processed. So this is the counter sewing. If we still remember on the previous chapter about counter, so counter is like you just go from the bottom to the top, and it's just gonna cut the whole thing. Hex sewing uses a reciprocating saw, either manually or mechanically operated, to perform a cut of operations. Cutting takes place only the forward stroke. So if you can see, I'm gonna draw around here. So this is, if you can imagine, this is the hacksaw. This is the part of the edges. So it's the sharpest one. When you go to cut, it's gonna move like it's a bit going down. So when you cut, you just go like zap, and then you take it away, zap, and take it away, zap, and take it away. So it moves like you push it down and then going up again and move it down again. Abrasive sewing uses a circular bend or just reciprocating saw blade with a cutting edge that consists of abrasive particles rather than teeth formed in the edge of the metal blade itself. Thin, circular cutters of bonded abrasive are most common. Surface speed are so much higher than the conventional sewing. Abrasive sewing is used when the workpiece material is hard or otherwise difficult to cut with metal cutting teeth. So abrasive sewing is usually just like the normal blade, but the edge is using like abrasive powder or material. Like this is the example, diamond edge sewing, but on the outer part is using abrasive. It's just something like that. And friction sewing is like the first one, but because the material is more hardened materials like Rockwell C42 or more, so it needs to be softened or gonna be preheated. Flame cutting. Flame cutting involves to underlay process the severing cutting or metal pieces by making a narrow slit, or you just gonna like continuous on flaming, and severing cutting by chemical action wherein the metal oxidizes at high heat. The cutting torch is often manually guided, and however, flame cutting machine guide you to merge accurately along straight line and curved paths. This is the oxygas view on gas cutting. You just see this one because it's gonna be lagging on my laptop. So the nozzle is filled by oxygen and acetylene or other fuel gas, and of course it happens in like open air, so it can torch gonna push in, and the gas metal or the slag is gonna go out. So that's all.
We think flame cutting started in around about 1899 in a chap in America called John.
Now is metal powder cutting or POC. Is a method applicable that not flame cut very easily. Preheated iron powder is injected. It's actually the same like high alloys schematic view. I'm gonna put the picture. And now chemical flux cutting. It's actually the same as well, but it has the flux injection. And arc cutting. Arc cutting involves a group of processes that use the heat of an arc to melt a metal pieces. Severing is removed. When the arc process are used to cut steel and other easily oxided metal, oxygen may be used in conjunction with the arc to support the oxidation. So if you can see here, the tungsten is for the corrected or as anode, and cooling water of course used as well because it's gonna be superheated, and the shielding gas is actually used as well so it doesn't explode. Plasma cutting is the same, just the difference is on the plasma. So plasma is like you are using the more higher gas. I mean the temperature is higher. Air carbon are cutting is the same as well. Oxygen lens cutting, this is a different one, so we're gonna see the video. I'm sorry, my internet is a bit late here. So now the cutting process is started. So that's all. We have gas metal ore cutting is actually the same one, so we don't need to talk about this one. And gas tungsten ore cutting is actually the same again, but we are using tungsten as the anode. Now the shielded metal ore cutting is the stick welding, because you need shield to make it without any gas jacket. The heat of high current density melts the workpiece and gravity to carry molten over metal. So shielded metal ore cutting is used for that. And carbon ore cutting is not a significant industrial process, but is found in a small shop that lack more sophisticated equipment. The arc between a carbon graphite electrode and the workpiece melts the workpiece where the arc contact. Gravity and pressure of the arc rather than the air jet use the air carbon ore cutting. Laser cutting. Laser cutting is usually the same like okay, we're gonna talk these operations. The heat generated by a powerful beam of coherent light melts and vaporizes workpiece material. The process works best with less than 0.2 inch thick, but can be used on greatly reduced cutting speeds with a metal up to 0.5 inch, but you're gonna cut it more longer, or the time you need to cut it is take more way longer. With thin materials, the process is faster than mechanical cutting. Holes can also be drilled rapidly, and you can search the video, or I'm gonna fix. But this one is different. The plasma cutting and laser cutting. Now we're gonna talk about electrical machining process. The first one we're gonna talk about electrical discharge machining, or EDM. Sometimes it's spark erosion machining. It uses a series of fine electrical discharge or sparks to erode the workpiece material. The discharge pass from the tool or cathode and to the workpiece or anode at a rate greater than 20,000 times per second. The workpiece material, which must be electrically conductive, melts or vaporizes at this point, where it touched by the spark. So that's all the electrical discharge machining, or EDM. Now we're going to talk about RAM EDM. It's sometimes called desinker, and the principle is illustrated on the figure below here. So this is the RAM, this is the workpiece, and the RAM is using reversible servo motor, of course. So the RAM is just gonna go up and down, but the electrical pump and filter here is using for the power, and this is the electrode. So it's just gonna move like up and down. RAM. If it is in downward into the work, but CNC counter can also provide transfer movement of the electrode to produce special shapes in the cavity. Wire EDM, it's just like the same, but using wire on the top and it's connected on the bottom. Use a constantly moving wire instead of a shaped electrode. tungsten, copper, and brass are common wire materials. The wire of the work is fed horizontally as the cut progresses to cut a slit, or you can just imagine a slit, or shape through a hole in the workpiece. Different wire material is constantly exposed to the spark, so where the wire is widely distributed and it is not a problem. Electrical discharge grinding, if we still remember about electrical discharge, and also the grinding. So it's just the mix between the two of them. It's similar to discharge machining, except the electrode is rotating wheel instead of an electrode that is stationary except its down feed. The workpiece and wheel are immersed in the electric fluid, and metal is immoved by the same kind of spark. The wiping action of the wheel produces the better surface finishes than with ram type idiom. The graphite wheel is depressed as necessary to compensate for its wear in the process. So, since the wheel wear is spread over its circumstance, the amount of reduction of wheel diameter from dressing is normally small, so it doesn't take a lot of the wheel diameter, so it's gonna be safe. And it's using the dielectromagnetical fluid, so it's gonna be safe for the blade. Electrochemical machining, it's using the chemical as well, but it's mixed with the electro. Removes metal by a reverse electroplating process. The workpiece becomes the anode and the tool is cathode of the electrolyte process. A highly conductive electrolytic fluid is pumped into the space between the workpiece and the tool, and high amperage current removes workpiece material by anodic dissolution. So the electrochemical machining is it goes using from the tank, of course, going to insulation set of electrode and gonna push again to the electrode, and this is the workpiece, the tool holder, and constant feed. So the feeding is gonna be keeping on. Electrochemical grinding is the same work, but it uses a bit of principle of electrochemical. And electrochemical turning, or ECT, is like electrochemical machining. The workpiece is rotated as in conventional turning, but the cutting is replaced by an electrode, so it's the same as like you turning and machining lathe. Electrolytic fluid is directed to the gap between the tool and the work, and material is removed by electrolytic action between the workpiece or anode and the electrode or cathode. Facing and turning cuts can be made. This forging and bearing races are machined by the process. We have the electrochemical discharge grinding. We don't need to talk about this one, and the honing as well is just the same electrochemical, but it's just used for honing. Electro-etching is a method for marking workpiece that are electrically conductive. A stencil is placed on the workpiece and pad containing an electrode is placed or depth the workpiece, and the pad are connected to source of the direct electrical current. And now we're gonna talk about finish machining operations. We have honing. With the previous one we have like electrochemical honing, so now we're gonna talk about honing. Honing is a low velocity abrasive machining process. One or more unbonded abrasive stones or sticks are put in the area of contact with the surface to be machined, in contrast with grinding processes, where the abrasive and the work are in contact essentially on a line. Okay, so that's the basic one. We have this one. This is the end section, and typical single stone abrasive honing in a hole. And the B1 is through, C is taper, and D is outrounded, and E is bowl shaped. Lapping is another low-velocity abrasive machining process. It utilizes a fine abrasive. It just The purpose here is just to abrasive between lap and workpiece to make it like more softer. Random reciprocating motion of the lap and the abrasive with the light pressure applied, prevents the dimension and smoothness of the workpiece to a close tolerance. Unlike honing, the motion is not necessarily in a more than one direction. Super finishing is a third low-velocity surface finement process. A solid abrasive is used, but it is loosely blended so that it wears the shape of the workpiece surface. Thus, a large surface area is contact with the abrasive at all times during the operations. So this is the pressure one here. It's just using it. The purpose here is just to make it softer. Burnishing is a means of smoothing machine. Burnishing is not machining operation. No workpiece material is removed, but instead the volumes and the presses down localized high spot from the cutting tools. And the last one is roller burnishing. It's just using roller. So that's all we're gonna talk about this one today, and I'll see you next time if you have any question, because of course it's too fast because I don't have so much time. I'm in a hurry. So see you guys next time.